Quantum entanglement. In the previous videos, we saw reality slowly slip out of its classical frame. Energy refused to behave as only a wave or only a particle. It refused to flow continuously, and it refused to carry precise position and precise motion at the same time. These were not separate ideas, they were warnings. Now, they led us into something even more unsettling: quantum entanglement. Quantum entanglement occurs when two or more particles are created or interact in such a way that their properties become deeply linked. So deeply linked that they can no longer be described independently, even when separated by vast distances. This does not mean signals are sent between them, this does not violate the speed of light, and this is not magic. What changes is not information traveling through space, what changes is how reality itself is described. Consider this. In the quantum realm, when particles are entangled, properties like spin or polarization do not belong to individual particles alone, they belong to the system as a whole. When a measurement is made on one particle, the result immediately tells us something about the other, not because one sends a message, but because the system was never split into independent parts to begin with. This is why Einstein famously called it spooky action at a distance, not because it broke physics, but because it broke classical intuition. Here's a crucial clarification. Even though outcomes are correlated, each individual result is still random. You cannot control the outcomes, you cannot send information faster than light. Entanglement predicts correlations, not messages. A useful analogy is this. Imagine two friends who agreed on a rule earlier and then went far apart. When one performs an action and sees the result, they immediately know what the other must see. Not because they communicated, but because the rule was shared beforehand. Quantum entanglement is similar, except the rule is not classical information. It is encoded in the quantum state itself. Quantum entanglement is a condition in which multiple particles share a single quantum state, such that their measurable properties are defined only in relation to each other, not independently. This is why entangled particles cannot be fully described on their own. Only the combined system has a complete description. This strange behavior has been tested again and again and confirmed. It is no longer a theoretical curiosity, it is now the backbone of quantum communication, quantum cryptography, quantum computing. Entanglement is strange, yes, but it is not supernatural. It is simply how reality behaves at its deepest measurable level. So, this brings us into the deeper question. If particles can remain connected beyond space and time, what does this say about separation itself? Is space fundamental or emergent? Is individuality fundamental or relational? And if nature stores information collectively, what does that imply about consciousness, evolution, or interconnected systems? These are not mystical questions, they are scientific frontiers, and we are only beginning. In the upcoming videos, we'll go deeper into quantum probability, quantum measurement, quantum computing, and beyond. A lot more quantum ideas, and their strange terminologies are on the way. Until then, question deeply, think clearly, and stay curious. Don't forget your formalities to our channel. Nandri, Vanakkam.